I'm Sam from Oxygen Tech, and today we're going to have a high-level look at the Flutter architectural overview. I'll try to keep this short as, again, it's a very high-level overview of the architecture of Flutter. If you're interested in going deeper, I will leave the link below to the Flutter documentation where it goes a bit more in depth into the Flutter architectural overview. I've tried to simplify things as best I can for people who don't have much experience with software to try to give an overview of how Flutter works and how software interacts with hardware. So first, I want to start by talking about software. So software is simply a list of instructions that tell the computer what to do. And it can be visualized, the way it interacts with hardware can be visualized in layers. I'm just going to draw a little diagram here. So starting from the bottom, we have hardware. This is your computer, your phone, whatever the software is interacting with. And on top of the hardware, we have another layer, is the operating system. So the operating system is a layer of hardware that allows you to interact with the hardware. And on top of that, we have another layer. So this is blue, the application. Use my handwriting. Software. So this is the part that Flutter falls into, the application software, which talks to the operating system, which talks to the hardware. And to interact with the application software, we have the user. So the user uses the application, which talks to the operating system, which talks to the hardware. They interact through interfaces. So for example, in between the application software and the user, we have a user interface. We have interfaces at each layer. So Flutter falls in, as I said, to the application software section. So this is where Flutter lives. So the user interacts with Flutter and Dart, the application, which talks to the operating system, which can then use the hardware, use some of its features. So what is Flutter? Flutter is a multi-platform user interface toolkit powered by Dart, which is the programming language it uses, and it's designed to allow code reuse between operating systems. Its goal is to enable developers to build high-performance apps that feel natural on different platforms. So using the same code base on different platforms in a way that feels completely natural. During development, Flutter apps run in a virtual machine, which uses stateful hot reload without the need of a full recompile each time a change is made. So I should just quickly note on compilation. So with Flutter, the code is written and then it's a compiled language. It compiles into code that can be executed by the operating system. So some languages are interpreted. So there's compilation and interpretation. So compilated languages like Flutter, Java, C++, their benefit is they can be executed quite quickly after they've been compiled, whereas interpreted languages, the code is interpreted line by line instead of all at once. It's interpreted and then run right line by line, whereas the compiled code is compiled once and then the whole thing is executed, which is already in a language that's understood by the operating system. So interpreted languages like Python and JavaScript, a couple of the examples, they can be a bit more flexible. That's their advantage, but compiled languages tend to be faster. So the underlying operating system, Flutter apps are packaged the same way as any other native application. So if you're using an Apple phone, you might have an iOS app. So the operating system, the iOS app is in a structure that it can execute through the hardware right away. And with Flutter, it is compiled into this form. So Flutter can go straight to be run by the operating system on the hardware. So I'm going to move on to, these are a couple of diagrams that are commonly used by Flutter. These are both included in the architectural overview. The diagram on the left is a higher level example than I think I'll go into detail today. It has a bit more detail, but I just want to point out this top part is a framework. So then the framework connects to the framework over here. I'm going to use the diagram on the right today. I just want to show embedder, the engine, and the framework are the two main parts of this diagram focuses on. So they are included in the diagram that we'll be using today. I'm just going to get rid of that. We're going to focus on this one right here. So focusing on this diagram, again, I just want to reiterate the Flutter architectural overview will go into more detail than this, but this again is just a high level example. So we're going to start from the top layer. So we have the Dart app. So it composes widgets into the desired user interface, and it implements business logic, which is functions, making the app do what it does. And then the framework, this is Flutter. So Dart and Flutter together are what we tend to interact with as developers. That's the part we'll typically be working with as developers in our everyday work. So writing the programs and giving them functionality, designing the user interface. That all happens at this top layer. So in a framework, we build the widgets that's responsible for gesture detection, accessibility, text input, and again, this is where we interact with the application. Moving down to the engine, things get a little bit more interesting. So the Flutter engine is written in C++ and C, as you can see over here, and is responsible for rendering the user interface, handling input events, and managing other low-level tasks. And it also provides an application programming interface for drawing graphics and managing animations, handling gestures, and talks to the embedder through this embedder API here. So this section, the Dart app, the framework, and the engine, these parts are platform agnostic, which means whatever platform we're coding for, these will be the same. And that's the beauty of Flutter. You can move it between different systems. And to enable this, we have the embedder. So the embedder is platform specific. So it is different for any system that you're operating on, whether that be an iPhone, iOS, an Android phone, a Linux desktop application, Windows application, a Mac OS application, whatever you're working with, the embedder is different. It provides the necessary bindings between the Flutter engine and the platform, to the hardware, to allow Flutter apps to run and interact with the underlying operating system. So it essentially translates the code into a format that is usable by the system being used. And many higher level features that developers use can be implemented as packages as well, including platform plugins like camera or microphone, web view, for example. This happens at the embedder level. So some people create packages or plugins that can be used for Flutter, and this is the level that it's implemented at. But in our everyday programming, we typically, as I said, just work with the Dart app and the Flutter framework up the top. But it is possible to delve into these lower levels if you have the adequate experience. Embedder is written in a language that's appropriate for the platform. So for Android, it might be Java and C++. For iOS, it could be Objective-C. And for Mac OS, it'll be the same, Objective-C. And for Windows or Linux, I believe it's C++ as well. And then we move on to the bottom layer here, the runner. It composes the pieces exposed by the platform-specific application programming interface of the embedder, which is right here, into an app package that's runnable by the target platform. So the runner is basically where the app is run on the operating system. So below this would be the operating system. So this whole chunk is the application software. Software talks to the OS, which then talks to the hardware. And that's how the programs run on a higher level. But this is applicable to mobile and desktop. There are some differences in Flutter Web. So the Flutter engine is typically written in C++, as we noted before, And it's designed to interface with underlying operating system rather than a web browser. The internet works differently, so a different approach is required. So here we have a different diagram. So again, I'm just going to focus on a higher level. So this framework, Dart framework, is Dart and Flutter. And Flutter, that is the app that we're working with, that we're programming. And then below here is what it's compiled into. It's compiled into JavaScript to be run on the browser. And the beauty of this is it can be compiled ahead of time. I mentioned before that JavaScript is an interpreted language, which means it's translated line by line and executed line by line, whereas Dart and Flutter is compiled into code that can be executed into optimized JavaScript so it can run nice and quickly on the browser as well. Well, now that we've had a bit of a run through of the architectural overview, that's as in-depth as I'm going to go. If you'd like to know more information, I'll leave a link below to the official Flutter architectural overview. But for now, let's build something.
Hopefully that overview made a bit of sense and you could gain some benefit from it. Since that was all a bit dry, I thought perhaps we could build something. So what I'm thinking today is we could build a Dart 8-ball application. So I don't know if you know about Magic 8 balls. So they're an old school kind of popular toy where the ball is filled with fluid and something like a 20-sided die or something like that. You ask the question, shake the ball, and then it reveals an answer. So some of the answers that can be revealed are shown here. So things like it is certain, don't count on it, ask again later. So I think what we can do is build an application that can generate a random number, and then based off whatever the number that is, it will give us an answer. So to use random number generation, the first thing we have to do is import Dart math. That'll give us the ability to access the random class. So let's create a variable, store the information, store the result. Actually, let's call it random number, random integer. It's a bit more clear. Equals random dot next int. So don't stress too much about what this means. Let's say 6 options will be enough. So I'm using the random class here to call a method on it called nextInt, which randomly generates an integer, and I've given it the number 6 here, so it'll be an integer between 0 and 5. I'd like to make it between 1 and 6, so I'm just going to increment that by 1 plus 1. All right, so I've written, don't worry about the final keyword here, but I'll just add the type here. So this is of type integer. This is what it'll return. I haven't gone into detail on data types yet, but I'll do that in probably my next video. So all you need to know is this is going to generate a random integer, which is a whole number. It won't be a decimal number. It'll just be a whole number. So, all right, we've got the random integer now. So now we need to create a function that's going to take that random number and then give us a message based off that. So we'll ask it a question and then it gives us this random message. So what we might do here, string generate response. Oops, ignore that P. We'll get rid of that. So generate response. We'll take an integer, which we will call random number. I just want to call it random number to differentiate it from this variable random integer up here. But random integer is what we're going to give to this function when we actually call the function. So generate the response. So I'm going to use a switch case here. So a switch is something where you give it a number of different cases, and based off each case, it gives a different response. So the cases that we're going to use are random number. So the random number could be any number between 1 and 6. So we need to write these cases. So the case where the random number is 1, we will return a string. Let's say, please ask again later. The most annoying answer we'll put first. Okay, case 2. Return. I'm going to use some classic Magic 8-ball terminology and say it is decidedly so. Case 3. Return. Don't count on it. Get rid of that little apostrophe there. So you might see I've put a backslash in here in front of the apostrophe. I went over this in my last video, but if you're using single quotes for your strings, it's important to have that backslash there to make sure that the program doesn't identify this as the end of the string of text. I'm using double quotes, so I don't need to have it, but I'm just putting it in there just as it's a good habit to have it there. So, all right, we need 3 more cases. So we've got an unsure, we've got a yes, and we've got a no. Let's see, case 4, return yes, another positive result. Case 5, return no, and just to make it balanced, for case 6, it'll return I am 100% unsure. And then with a switch statement, it's important to have a default value as well. That's why we're getting an error up here. Because if this executes and the number given is not between 1 and 6, it won't know what to return. So it'll just return null, which is a no value, and we don't want that. So default return, there was a miscalculation. And that just means I've generated a number that's not between 1 and 6, which would mean there's an issue with this section here. All right. So that error should go away, I think, because I've put the semicolon there. So we are going to call the generate. So we're going to print it. We want to print this so we can see the result. So generate response. And we're going to give it the random integer. And a semicolon there. So that should print whatever response goes with this. So first I'm just going to change this to 100. Let's see what happens when I run the program. Okay, so I can see there was a miscalculation. So I've done this just to demonstrate that I did 100 because that'll be any number between 1 and 100, and it's highly unlikely that was between 1 and 6. I just wanted to show that this would return there was a miscalculation because the number was not between 1 and 6. So now if I change this back to 6 and I run it, it should have one of these results, one of the 6 results. So what question can we ask it? Will I win the lotto tonight? And let's run. I am 100% unsure. That's actually quite a wise answer. This is a great program, obviously. Shall we ask another question? Will this video get more than 1 viewer? Don't count on it. Another wise response. So it's just a fun little program you can build in Dart. So feel free to copy this down, have a play, change the answers, add more answers if you want. I think in the traditional Magic 8-ball there was around 20 potential answers, just something a bit of fun. So in my next video I hope to cover some fundamentals of Dart programming language. So I've already been using a few things like variables and data types, but I'd like to dig a bit deeper into that next video just to tell you what the main types are. So integer we've used, string we've used, but I just want to go into a bit more depth of what they are, how they can be used, and how we can make more complex programs. So thanks for watching, and I'll see you next time.